Well, greetings, Mr. Kolazar's class. We're going to look into Chem Video 3.5, classifying matter. And to begin with, we're going to break it down into, first off, we're going to classify just the pure substances. A pure substance, matter with a uniform composition or unchanging. So it's the same throughout. If we were to take just like one little speck of salt or a whole bunch of salt, salt the whole way through is a chemical formula, sodium chloride, and it's just salt. Or pure water without anything in it, it's just H2O. So if you have a little bit or a lot of it, it's exactly the same. You cut it in half or in a smaller amount, you have just the same amount as our pure substance. One version of a pure substance is the element. Pure substance that cannot be separated into smaller substances by physical or chemical means. Elements are on the periodic table, like carbon, or nitrogen, or oxygen, or iron. So any element symbol you see, if it's just its element symbol, would be from the periodic table, would be an element. Now, on the back page of your notes, we're starting out with our matter, and right now we're breaking onto this side, our pure substances, which is going to be just right now our elements or our compounds. So all of these are just our pure substances we're going to look into. So the elements, 118 on the periodic table, 92 occur naturally on Earth, and the other 26 are synthetic or man-made elements. So synthetic would be to be made by man. Each element has a unique atomic number and composition. How are we going to write our element symbols out this year? Chemical symbol is going to be our shorthand way. They're either 1, 2, or 3 letters that represent the element. The first letter is always capitalized. And if there's a second or a third letter, it's always lowercase. So we would have like Na for sodium. Capital first letter, lowercase second letter. N for nitrogen versus Ni for nickel. So that we see a lowercase letter. We don't want that to get confused with a capital I for iodine. So first letter always capitalized, second letter lowercase. Our periodic table organizes all of our elements into two ways. Our periods, which go left to right on the periodic table, so going across to row. And our second way is into groups, going up and down. Now the groups that go up and down have similar chemical properties. So everybody in the first group has similar chemical properties, the second group, the third, but each line going down the periodic table has similar chemical properties. If the substance is listed on the periodic table, then it is an element. Now compounds are when two or more elements chemically combine together. So if two or more elements chemically combine together, say if we take hydrogen and oxygen to make H2O, we would actually get a new compound being formed. They can be separated back to their elements only by a chemical change, not physical changes. So the properties of compounds are different than the elements that make that up. Remember this one. Now, a couple ideas. The textbook gives us the example: potassium is a metal and iodine is a purplish gas. When combined together, they make potassium iodide. Potassium iodide is a salt substitute, so it's a little bit different there between the silvery metal and the purple gas. Or I'd like to also give you the example: sodium and chlorine to make sodium chloride. Sodium is a very soft metal that explodes when it comes in contact with water or air, over on the side here. Chlorine gas is a greenish yellowish gas, which is toxic. It was our first chemical warfare gas over here on the right. If we chemically combine the two, it forms a white crystalline solid known as sodium chloride or table salt. So again, showing our compounds properties different than the chemicals that make them up.